Hey guys, my name's Ryan. I'm a tutor in the Econ Tutoring Center. Today I'm going to go over an example of finding the profit maximizing quantity, profit, and price for a monopoly. So remember that notation and language may vary by professor, so always check to make sure that the language that we're using is the same as your professors. Okay, so in this example we are given the demand curve, the monopolist's marginal revenue, and our marginal cost here. So note that our marginal cost in this case is just constant, so it'll just be a line at 4. But in other cases you might see this being an upward sloping line, but it works in either case. Okay, so here we'll go ahead and plot these things first, and then we can go into finding graphically what our optimal quantity and price are. Okay, so this is going to have a y-intercept of 200. And then it'll just be a downward sloping line with slope of 1/5. It'll get somewhere like that. So this is going to be another line also starting at 200, but with twice the slope. So it'll be just a steeper line like this. So this is our demand. This is our marginal revenue, right? And then our marginal cost, like I said before, is just a constant 4. So it'll be right here. And that is our marginal cost. Which is just the same as our average cost in this case because everything is just 4. So the reason for that is that you pay the cost of any additional unit is $4, and because that's just constant, that's also going to be the average cost of every unit, and that is $4 right there. Okay, so remember for a monopolist or for any profit maximizing entity, they look to set marginal cost equal to marginal revenue, and that'll find the optimal quantity. So here we go, marginal revenue equals marginal cost, and they go up to the demand curve to find the associated price right here. So this is our P star and this is our Q star. So we want to find that price and quantity. So I'm going to go, like I said, where marginal revenue equals marginal cost. So I set marginal cost 4 equal to our marginal revenue, which is 200 minus 2q over 5 minus 2q over 5, and now I'm just going to solve for q here, and that'll get me that 2q over 5 equals 196. 196 divided by 2 is equal to 98. And then we just need Q star is equal to 98 times 5, 490. So that gets us this optimal quantity here is 490. Okay, and remember we just did that by setting marginal revenue equals marginal cost. And that gives us this optimal quantity. And like I said before, we take this quantity Q star, we plug it back into the demand function to find out what that price is. 200 minus 490 over 5, 102 it looks like. Right, and so that is this P star right here is 102. So we just took this quantity, plugged it into this equation for the demand curve, which is this, and that gave us our P star back. So this is the profit maximizing quantity and price for the monopolist in this case, with this marginal cost, this demand, and this marginal revenue curve. Right, okay, so now we can go ahead and calculate what the monopolist profits are. Okay, so we want to know what their revenue is. So for each unit, the revenue that they make when they sell a unit here is $102 because that's the price they charge. So, and then the cost for each unit is just this average cost, which is 4. So on each unit, they're making $98 of profit, right? Because they're selling each one for $102, but each one costs them $4, right? So then the profit there is just that quantity, 98, times the amount of units they sell, which is 490, which gets us the area of this box as their profit. So this right here this is profit. right? In another case, when you might not have a horizontal marginal cost curve, you're going to look at the average total cost curve here to find what your cost per unit is. But in this case, because it's horizontal, we just get to go down to this horizontal line here. But anyway, you can just calculate that by taking 98 times 490, 48,020. That's our profit. So that's the profit right here, and some people call that pi. So that's our profit for the profit maximizing monopolist. So they sell 490 units for $4 each. I'm sorry, for $102 each, and each one costs them $4. So they make $98 on each one, and they're selling 490 of them. So they end up with a profit of $48,020. Okay, so the last thing I'm going to calculate here is the deadweight loss. So remember when we were in a monopolistic situation here, the consumers got this bit, and the monopolist got this lower bit here, right? When we are in competition and we're down here, all of this is consumers, right? So the difference here, the net loss is just this blue area right here, right? This blue area is our deadweight loss from moving from a monopolist from moving from competition to a monopolist. So this is our deadweight loss. And so the way we calculate is just by calculating the area of a triangle. And the height's going to be 98. So this height is 98 here. And then we just need to find what this difference is. And the way we do that is by finding first QC. So what is the competitive quantity here? And we do that by setting marginal cost equal to demand. So I can do that right now. So that will be marginal cost is 4 equals 200 minus Q over 5. So Q over 5 equals 196, which means that QC is equal to 196 times 5, which is, let's see, that is 980. So 980 right here. Okay, so now I have everything I need to find my deadweight loss, just the area of this triangle. So our deadweight loss is equal to 1/2. So remember, it's just 1/2 base times height. So our height is 98, and our base in this case is 490. 490. Right, and that is because that's just the difference between 980 and 490. And then if we multiply that out, that gives us 24,010. Right, and that is our deadweight loss. Okay, so I hope this example gave you a better idea of how we can actually calculate, given a demand curve, a marginal revenue, and a marginal cost, how we could calculate deadweight loss would be from moving from competition to this monopolist. A monopolist profits, the optimal quantity, and price. So the last thing I would remind you of again is that this is a special case when our marginal cost is constant, which means it's equal to our average cost. But if marginal costs were increasing, then we would have a separate average cost curve that we would have to use to calculate our profit. So always be on the lookout for that if you're asked to do a question like this where marginal cost is not constant. If you have any other questions or need any other help, come visit us in the Econ Tutoring Center.